From problem set 2. I'm going to do the first two questions on this video, and then I will do the third question on a separate video. So for the first two questions, I'm going to do, so the first one is to compute the average path length of a line with n nodes. Okay, so it's something like this, and an ending node there. So if I number the nodes, this is n minus 1 and this is n. So I have a total of n nodes. And the average path length is going to be, well, the distance between any 2 points here is going to be dij, is going to be the absolute value of j minus I, okay? So I can say that the average path length is going to be equal to, well, what I'm going to do, since we have to do all the possible combinations, okay? So this is going to be equal to, I'm going to take the second node larger than the first one, okay? So it's going to be farther on the right than the first one. So this is going to be 2 divided by n times n minus 1, okay? Times the summatory of from I equal to 1 until n minus 1 of the summatory from j equal to I plus 1 until n of dij, right? This is the right definition, and this is the right normalization, okay? The number of terms that I have in this addition, seem I'm making j to be strictly larger than I, is going to be 2 over n times n minus 1. Okay, so that's the idea. And now what I'm going to do is to rewrite this expression with the original formula. Okay, so this is 2 over n times n minus 1, the summatory on I. And then this is going to be the other summatory, okay, from j equal to I plus 1 until n. And this is j minus I, okay? And I don't have to write anymore this absolute value, okay? So this absolute value, I don't have to write it because I'm ensuring here that j is greater than I. So this subtraction is always going to be larger than 0, greater than 0. So this, what I'm going to do is to rewrite this expression using another index. So I'm going to define a new index, which is going to be j minus I. Okay, so now this index, instead of going from I minus 1 to n, then k is going to start at, for j equal to I plus 1, this is going to be, the lower value is going to be 1, and the larger value of k is just when I substitute in this expression, okay, in this expression, when I substitute j equal to n, which is the largest value that it can take. So in this case, it's going to be n minus I. Okay, so that is going to be the two bounds for this new way of writing this summatory, but it's the same. The result is going to be exactly the same. The only thing that I'm doing is changing that variable, okay, so to make it easier to do the addition. So this is going to be the summatory from k equal to 1 until n minus I of k. Okay, this is k. Remember that this was equal to k. Now, this thing over here, this is the addition of the first n minus I natural numbers. And this has a formula, okay? And the formula for this addition, this has a formula, okay? And what I'm going to use is that the addition from n equal to 1 until n of n, this is equal to n times n plus 1 divided by 2. Okay, so now in this case I have k, okay? And the last number that I'm going to add is n minus I instead of n. So here, instead of writing n, I have to write n minus I, and the same goes here. So for this expression, this is equal to, the first two parts are exactly the same. Okay, so I have to write n divided by, 2 divided by n times n minus 1, and this summatory is exactly the same because I didn't finish this part. It's just for the second summatory, okay? So in this case, what I have, okay, I'm going to I'm going to substitute n minus I in the previous expression. So this is n minus I times n minus I plus 1 divided by 2. Okay, so this is the expression that I'm obtaining here. Now this second expression, okay, so I can cancel out these 2's here, and I have a second expression which I can rewrite also in terms of another variable. So this is, you can see that this is the multiplication of two consecutive numbers, okay? At I equal to 1, this is n minus 1, and this is n minus 1 plus 1, which is n. So the last, for I equal to 1, this is n minus 1 times n, okay? So that's the first term. And the last term is going to be for I equal to n minus 1. So for I equal to n minus 1, I would have n minus I would be equal to 1, and I would multiply it by 2, okay, because it's n minus I plus 1, so it's the next number. So really, this is the summatory, okay, so I'm going to rewrite this summatory as well, like this. And then this summatory, in terms of doing it in terms of I, am doing it again in terms of k, to n minus 1 of k times k plus 1. Okay, so this is the expression that I obtained. Now, this is another expression which is similar to the previous one, okay? In this case, we had this expression, and in this case, we have this other expression. There is a general formula for this kind of expressions, okay? So the general formula is going to be that, if I remember correctly, the addition from n equal to 1 until n of n times n plus 1, this is going to be equal to n times n plus 1 times n plus 2 divided by 3. Okay, and if you do the addition, if you do the same with n times n plus 1 times n plus 2, okay, this is going to be the same as m times n plus 1 times n plus 2 times n plus 3 divided by 4. Okay, so this is a general formula. So in this case, what we have is that now what I have is this expression. Instead of n, I have n minus 1, but the rest is the same. So I have to write here, the first part is the normalization constant, okay, in order to do the average. So this is for the average. And now I have the expression, this expression, where I have to write, instead of n, I have to write n minus 1. So the first term is n minus 1, the second term is n, and the third term is n plus 1. And I have to divide everything by 3. So now this n cancels out this other n, and this n minus 1, this other one. So in the end, I have n plus 1 divided by 3. So this is going to be the average path length of this line. Okay, so we have n plus 1 divided by 3, and that's it.